Good day. Previously I gave you exercise 1.2. We have a few corrections to make. Go to problem number 2. That problem as is in your notes right now is ill-posed. So please make the following corrections. The problem will read, given the quadratic equation rx squared minus into r plus 6 rx squared minus into r plus 6 and not 2r plus 4 r plus 6 all into x plus 6 equals 0. Please correct that. But now go to problem 3. Given 2x squared plus is going to be 2 into 2x squared is going to be the problem given. The right problem is going to be x squared plus 2 into r minus 5 all into x plus r squared plus 4r equals 0. R squared plus 4r equals 0. So the problems will read, given x squared plus 2 into r minus 5x plus r squared plus 4r equals 0. Find the value of r where r is a real number. These are problems 2 and 3 of exercise 1.2. So now we're going to do the solutions to the problems in exercise 1.2. Question 1. Show that the following equations have real roots and determine the real roots. So 1a, given x squared plus 2x plus 3 equals 0. Clearly, a equals 1, b equals 2, and c equals 3. Recall the formula for the discriminant. Recall delta equals b squared minus 4ac. And substitute for a, b, and c. In delta, we have delta equals 2 all squared minus 4 into 1 into 3, which implies delta equals 4 minus 12, which is equal to minus 8. Clearly, b squared minus 4ac is less than 0. Thus, the equation has imaginary roots. Imaginary or complex roots. Let me give you a few minutes to scribble down something. If we go on to problem B, 1b, x squared plus 2x plus 5 equals 0. Clearly, a equals 1, b equals 2, and c equals 5. We know that delta equals b squared minus 4ac, which implies delta equals 2 squared minus 4 into 1 into 5, which is equal to 4 minus 20 is equal to minus 16. This implies that b squared minus 4ac is less than 0, implying equation has imaginary roots. Now, for those of you who may not have understood what we're doing here, if we are given this equation, x squared plus 2x plus 3 equals 0, clearly we have a equals 1, b equals 2, and c equals 3. You will recall that the discriminant delta is given by b squared minus 4ac, and if we substitute for a, b, and c in delta, we have delta equals 2 squared minus 4 into 1 into 3, implying delta equals 4 minus 12, which is equal to minus 8. Clearly, b squared minus 4ac is less than 0. Thus, the equation has imaginary roots. Same argument goes for problem B. Now let's do problem C, 1C. Given x squared plus 7x plus 12 equals 0. we see that A equals 1, B equals 7, and C equals 12. Recalling the formula for the discriminant, delta equals B squared minus 4AC. And substituting for A, B, and C in delta, we have for A, B, and C in delta, we have this is A, B, and C in delta. We have delta equals 7 squared minus 4 into 1 into 12, which is equal to 49 minus 48, which is equal to 1. Clearly, B squared minus 4AC is greater than 0, which implies the equation that the equation has two distinct real roots, real roots. And these real roots could be computed here as follows. Now we recall the almighty quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac over 2a. And substituting for a, b, and c in the formula above, we have x equals minus 7 plus or minus the square root of 7 squared minus 4 into 1 into 12 all over 2, which gives us x is equal to minus 7 plus or minus the square root of 1 over 2, implying x is equal to minus 7 plus or minus 1 over 2, which results in x1 being equal to minus 7 plus 1 over 2, which is equal to minus 3. And x2 being equal to minus 7 minus 1 over 2, which is equal to minus 4. And the solution is complete. For those of you who have not clearly seen what is going on the bar, I will take this all over. Given the equation x squared plus 7x plus 12 equals 0, we know clearly that a equals 1, b equals 7, and c equals 12. If we recall the equation, the formula for the discriminant, delta equals b squared minus 4ac. Substituting for a, b, and c in delta, we have delta equals 7 squared minus 4 into 1 into 12, which is equal to 49 minus 48, which is equal to 1. Clearly, b squared minus 4ac is greater than 0. which means the equation has two distinct real roots. If we recall the almighty quadratic equation, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And we substitute for respectively for a, b, and c in the equation. We have minus 7 plus or minus the square root of 7 squared minus 4 into 1 into 12, which yields minus 7 plus or minus the square root of 49 minus 48 all over 2. So that gives you minus 7 plus or minus the square root of 49 minus 48 all over 2. Clearly, x is equal to minus 7 plus or minus the root of 1 all over 2, which is x equals minus 7 plus or minus 1 over 2, which yields x1 to be minus 7 plus 1 all over 2, which is equal to minus 3, and x2 to be minus 7 minus 1 all over 2, which is equal to minus 4. And the solution is complete. Okay, now let's go on to doing problem D. 1D. One D, given the equation x squared minus 5x plus 16 equals 0. Clearly, a equals 1, b equals minus 5, and c equals 16. If we recall the formula for the discriminant, recall delta equals b squared minus 4ac. And if we substitute respective values of a, b, and c in delta, we have delta equals minus 5 all squared minus 4 into 1 into 16. This gives us 25 minus 64, which gives us minus 39. Clearly, a squared minus 4ac is less than 0. Thus, the equation has imaginary roots. So like we said in previous examples, given x squared minus 5x plus 16 equals 0. Clearly a equals 1, b equals minus 5, and c equals 16. We recall the formula for the discriminant. Delta equals b squared minus 4ac. And we substitute the values of a, b, and c in delta. We have minus 5 all squared minus 4 into 1 into 16, which is equal to 25 minus 64, which results in minus 39. Clearly, b squared minus 4ac is less than 0. Thus, the equation has imaginary roots. Once the equation has imaginary roots, you don't need to bother yourself going to look for roots, because the roots will be complex, and we're not dealing with complex numbers right now. Okay, let's do problem 1e. Given x squared minus 8x plus 16 equals 0. Clearly, a equals 1, b equals minus 8, and c equals 16. If we recall the formula for the discriminant, recall delta equals b squared minus 4ac. Substituting for a, b, and c in delta, we have delta equals minus 8 all squared minus 4 into 1 into 16, which is equal to 64 minus 64, which is equal to 0. Clearly, b squared minus 4ac is equal to 0. This implies the equation has repeated real roots. The equation has repeated real roots, which could be reckoned as follows: x squared minus 8x plus 16 equals 0. Now we can factorize. This is, since it has repeated real roots, we look for the factors of 8. We look for the factors of 16, I'm sorry, which when added will give us minus 8. The factors of 16, which when added will give us minus 8, will be minus 4 and minus 4. So now we transform the above equation to the form x squared minus 4x minus 4x plus 16 equals 0. If we bring this into bracket, if we bracket this will become plus into minus 4x into 0. So if we bring x out here, this gives us x minus 4. If we bring minus 4 out here, this gives us x minus 4 into x minus 4 equals 0. Clearly, we see that the above equation becomes x minus 4 into x minus 4 equals 0, which implies x minus 4 all squared equals 0. implies x1 equals x2 equals 4. This implies x minus 4 equals 0, which yields x1 equals x2 equals 4. So for those of you who don't understand the factorization method, this is how we go about it. We look at this equation, go to the product term or the constant term, look for the roots of the constant term, two factors of the constant term, which when added will give you the coefficient of x here. And these two numbers, these two factors are minus 4 and minus 4. So it's evident on the board that the problem is a straightforward one. And students need to put in some time to practice these problems. With math is practice. Practice makes perfect in mathematics. There's no magic in mathematics. Okay, let's go now to problem 1F. Given 4x squared minus 12x plus 9 equals 0. Clearly, A equals 4, B equals minus 12, and C equals 9. If we recall, delta equals b squared minus 4ac, and substitute for a, b, and c in delta, we have delta equals minus 12 all squared minus 4 into 4 into 9, which yields 144 minus 144, which is equal to 0. Clearly, b squared minus 4ac equals 0, which implies the equation has repeated real roots. Implies thus the equation has repeated real roots, which could be reckoned as follows: 4x squared minus 12x plus 9 equals 0. We multiply this by this, it will give us 36. Now we look for the factors of 36. Look for the factors of the product AC. The product AC, which when added will give us B. Clearly, AC is equal to 4 times 4 times 9, which is equal to 36. And the two factors are minus 6 and minus 6. So the above equation becomes 4x squared minus 6x plus 9 equals 0. If we group this with the brackets, put a plus here and put the minus 6 inside here, we have that. Now if we bring out 2x here, that will give us 2x minus 3 plus, 2x minus 3 minus 3 into 2x minus 3 equals 0, which implies 2x minus 3 into 2x minus 3 equals 0. Which implies 2x minus 3 all squared equals 0. A thing which yields x1 to be equal to x2 equals 3 over 2. And the solution is complete. For those of you who didn't understand what was going on, first we needed to prove that the equation had real roots, and we started by looking for the discriminant, b squared minus 4ac. Clearly we saw here that b squared minus 4ac was equal to 0, meaning this equation has repeated real roots. Now, in order to solve for the equation, for the roots of the equation, we look for the product AC, which gives us 36. We look for the roots of AC. We look for the factors of AC, which when added will give us minus 12. And those factors are minus 6 and minus 6. Now we transform the above equation in this form. 4x squared minus 6x plus minus 6x plus 9. Then we try to factorize, and once we do that, we realize that the equation becomes 2x minus 3 all squared equals 0. The thing which results in x1 being equal to x2 being equal to 3 over 2. And the solution is complete. Now let's go on to problem 2. I'll read the problem. I'm not going to copy it and write it at the back because you already have it. If you don't have it, go to previous lessons. You'll see it there and make the corrections I'm going to make. Problem 2 now reads, given the equation, given the quadratic equation, rx squared minus into r plus 6 x plus 6 equals 0. Find the value of r, where r is a real number, for which The above equation has repeated real roots. Find the roots of the quadratic equation using the value of r determined. Now, we'll see clearly here that A equals r, B equals minus into r plus 6, and C equals 6. So for the equation to have repeated real roots, b squared minus 4ac must be equal to 0. Listen, for the equation to have repeated real roots, b squared minus 4ac must be equal to 0. So if we substitute our respective values for a, b, and c in b squared minus 4ac equal to 0, we have substituted for a, b, and c above. We have minus into r plus 6 all squared minus 4 into r into 6 equals 0. This gives us r squared plus 12r plus 36 minus 24r equals 0. I expanded this offhand, which results in r squared minus 12r plus 36 equals 0, resulting in, look carefully, this is another quadratic equation. So look for the factors of 36, which when added will give us minus 12. These factors are minus 6 and minus 6. So the above equation becomes r squared minus 6r plus 36 equals 0. Which implies r into r minus 6 minus 6 into r minus 6 equals 0. This yields r minus 6 all squared equals 0, implying r minus 6 equals 0, which yields r equals 6. Now, if we substitute for our r in the original equation, for r in the quadratic equation, we have 6x squared minus into 6 plus 6x plus 6 equals 0. Which implies 6x squared minus 12x plus 6 equals 0. We can divide all through by 6 and this will yield x squared minus 2x plus 1 equals 0. Which yields, take note, we are going to do, there's no space, so we're going to do it shorthand. We look for the factors of 1 which when added will give us 2, and these factors are minus 1 and minus 1. So in shorthand form, this will become x to the x minus 1 all squared equals 0, which implies x equals 1. There's no magic in this solution. You need to use your simple understanding of the basic principles underlying quadratic equations and the existence of the roots of a quadratic equation. So all we do here is to invoke the discriminant, the formula for the discriminant. So given this equation, rx squared minus r plus 6 into x plus 6 equals 0. Clearly, a equals r, b equals minus into r plus 6, and c equals 6. If we recall the equation for the discriminant, b squared minus 4ac is equal to 0. Because the equation has to have repeated real roots. The question, what we're looking for are repeated real roots. So in this case, b squared must be equal, b squared minus 4ac must be equal to 0 for this quadratic equation to have repeated real roots. Substituting for a, b, and c in the above formula, this formula here, b squared minus 4ac equals 0, we have minus into r plus 6 all squared minus 4 into r into 6 equals 0, which yields r squared plus 12r plus 36 minus 24r equals 0. This implies r squared minus 12r plus 36 equals 0. Clearly, minus 6 and minus 6 are the factors of 36, which when added will give us minus 12. Take note, this is the result of the expansion of r minus into r plus 6 all squared. So now factorizing, we have here r squared minus 6r plus 36 equals 0. So trying to factorize, we bring out r in this case, and that will give us r minus 6. We bring out minus 6 in this case, it will give us r minus 6. 6 into r minus 6 into r minus 6. So the total will be equal to 0. Now we realize that this will result in r minus 6 all squared equals 0, implying that r minus 6 equals 0 and r is equal to 6. Substituting for r in the quadratic equation, we have 6x squared minus 6 plus 6. 6x squared minus into 6 plus 6x plus 6 equals 0, which implies 6x squared minus 12x plus 6 equals 0. Simplifying gives you x squared minus 2x plus 1 equals 0, which by inspection is equal to x minus 1 all squared equals 0. By implication, x is equal to 1. And the solution is complete. So take this down. Now let's do problem number 3 of exercise 1.2. That's the last problem. Now I'll read the problem. Given x squared plus 2 into r minus 5, x plus r squared plus 4r equals 0. Please change the problem, change the equation in your books to read as follows: x squared plus 2 into r minus 5x plus r squared plus 4r equals 0. Given x squared plus 2 into r minus 5x plus r squared plus 4r equals 0. Find the value of r where r is a real number for which the above equation has repeated real roots. Find the roots of the quadratic equation using your values for r. So now we recall. First of all, we know clearly that a equals 1, b equals 2 into r minus 5, and c equals r squared plus 4r. Now we recall the formula for the discriminant. Delta equals b squared minus 4ac. And for the above equation to have repeated real roots, delta must be equal to 0. So if we substitute the values for a, b, and c in delta, we have, substituting, for a, b, and c. In delta, we have two into r minus 5 all squared minus 4 into 1 into r squared plus 4r equals 0. Which implies four into r squared minus 10r plus 25 minus 4 into r squared plus 4r equals 0, which gives us 4r squared minus 40r plus 100 minus 4r squared minus 16r equals 0. This implies this goes away, we'll have minus 56r plus 100 equals 0, which implies r equals 100 over 56, which is equal to, we'll use our calculator here. This gives us 1.786. So now if we substitute for our value of r in the quadratic equation, we have x squared plus 2 into 1.786 minus 5 x plus 4 into plus 1.786 all squared plus 4 into 1.786 equals 0. So we're going to use our calculator to simplify all of this. So this yields x squared plus or minus, that will be minus because 5 is greater than that, minus $6.428 x plus 1.786 squared plus 4 times 1.786. $10.33 equals 0. So now we can solve this. We already know that in our second equation, clearly a equals 1, b equals minus 6.428, and c equals 10.33. Recall x equals minus b plus or minus the square root of b squared minus 4ac over 2a. Substituting for a, b, and c in the formula, we have x equals 6.428 plus or minus the square root of minus 6.428 all squared minus 4 into 1 into 10.33 all over 2. This implies x equals 6.428 plus or minus the square root of 41.32 minus 41.32 all over 2, which is equal to 6.428 over 2 plus or minus 0. This implies x1 equals x2 equals 3.214. And the solution is complete. For those of you who couldn't follow the arguments in this problem, we're given x squared plus 2 into r minus 5 bracket x plus r squared plus 4x plus r squared plus 4r equals 0. Now we are told to look for the value of r. So for us to get the value of r, we have to meet the condition that this equation has repeated real roots, and that condition is b squared minus 4ac equals 0. So if we substitute for the respective values of a, b, and c in b squared minus 4ac equals 0, we have this here. So this results in this, which further results in this equation, and if we further simplify, we have minus 56r plus 100 equals 0, which gives us r equals 100 over 56, which is 1.786. Now if we substitute this value of r in this equation here, we will have this, which is x squared plus 2 into 1.786 minus 5 bracket times x plus 1.786 all squared plus 4 into 1.786 equals 0. On further simplification, we have x squared minus 6.428x plus 10.33 equals 0. Clearly, a equals 1 in the new equation, b equals minus 6.428, and c equals 10.33. If we invoke our almighty quadratic formula, we'll see that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Slotting in the respective figures for a, b, and c, our new a, b, and c, we have x equals 6.428 plus or minus the square root of minus 6.428 all squared minus 4 into 10.33, which reduces to x equals 6.428 plus or minus the square root of 41.32 minus 41.32, which clearly gives us x equals 6.428 plus or minus 0 all over 2. This results in x1 equals x2 equals 3.214, and our solution is complete. See you in the next lecture.